Hi sir, I am Midshipman Jacinto from G2C. So I am here to discuss about the ship stress and the measure on board to counteract the effect. There are 7 common stresses in ship. So the first one is hugging. So hugging occurs when the ship's center experiences upward buoyant force due to being supported by a wave crest, while the bow and stern are subjected to downward forces from the weight of the ship. So ang effect ani is the ship keel bend upward in the center, stressing the upper deck in tension and the bottom in compression. So hugging is a ship phenomenon where the center experiences if upward ang buoyant force from a wave crest. So while ang bow and stern face downward forces, so mao ni ang mag-cause og bending moment causing tension and compression. So in the upper deck and hull. So nay potential nga mo ni mag-lead sa structural damage. So next, sagging. Sagging what happens when the bow and stern are supported by wave crest while the center of the ship is in a wave through, causing downward forces in the center. Effects: the ship's keel bends downward, stressing the bottom in tension and the upper. So sagging is structural stress experienced by a ship when its bow and stern are supported by wave crest. So while the center of the ship is in a wave through, this situation creates downward forces in the center of the vessel. So the weight of the ship along with the lack of support in the middle, so mo ni magkakos o keel to bend downwards. This downward bending puts the bottom of the hull under tension or stretching, mainat, and the upper deck under compression, squeezing or maipit. Like hugging, sagging can cause significant stress and potential damage if the forces are excessive. The degree of sagging depends on factors like wave characteristics, ship design, and cargo distribution. So the third one, shear forces occur when adjacent sections of the ship experience unequal vertical forces, especially the near of the midship are or where weight distribution changes abruptly. So effects causes structural deformation and potential failure at weak points, deck, and comparison. So what I said, shear forces on a ship occur when adjacent sections of the hull experience unequal vertical forces. So this is particularly common near the midship area or in location where the weight distribution changes abruptly. The unequal forces cause a shearing effect attempting to slide one section of the ship past another. This can lead to structural deformation and potential failure at weaker points in the ship structure, potentially resulting in damage to the deck or other parts of the vessel. So, na posibleng mo ni ang resulta sa kadaot sa deck o sa ubang mga bahin sa barko. So, the magnitude of shear forces depends on factors such as the uneven distribution of weight, wave action, and the ship's design. Torsional stress, so generated when the ship is subjected to twisting forces, often due to uneven wave action on the port and starboard sides. Effects leads to twisting of the hull, particularly in ship with wide decks like container ships. So torsional stress is a ship is caused by twisting forces. These forces are often generated by uneven wave action, impacting the port and starboard sides of the vessel differently. So what I said lately, so the unequal forces cause twisting or turning moment on the hull, leading to torsional stress. So ang dili patas nga persa mao hinungdan sa usa ka pagliko sa kasko nga musangput sa torsional stress. So this type of stress is particularly significant in ships with wide decks, such as container ships, because their larger size and shape make them more susceptible to twisting. So the stress can cause structural deformation and potential damage if it exceeds the ship design limits. So we are in fifth or five, painting, alternating inward and outward movement of the hull plates near the bow or stern due to changes in water pressures as the ship pitches or encounters waves. So effects can lead to fatigue and weakening of hull plating. So painting is a ship refers to alternating inward and outward movement of the hull plates near the bow and stern. So this movement is caused by changes in water pressure as the ship pitches. So move siya og up or down. So or encounter waves. So ang movement sa cause changes in water pressure as the ship pitches. So move na siya, no? Move up or down or encounter waves. So the pressure changes cause the plates to bulge inward and outward, similar to the way nostrils flare. So over time, this repeated flexing can lead to fatigue and weakening of the hull plating, potential causing structural issues. So next, or the sixth one, is pounding or slamming. The repetitive and forceful impact of the bow and flat bottom sections of the hull against waves when the ship moves at high speed or in raw seas. So effect causes localized damage to the bow or keel area. So pounding, also known as slamming. So as what I said, it is a repetitive and forceful impact of a ship bow and flat bottom section against wave. So may tabo ra kini kung ang usa ka barko kay maglihok sa kusog nga tulin kapag dagan sa paglawig sa mga bawd sa kadagatan. So the repeated impacts can cause localized damage to the bow or keel area of the vessel. So pwede nga mao ang epekto sa pagbalik-balik o mao ang hinungdan sa lokal nga kadaot sa bow or keel nga lugar sa barko. Last one, rocking. Side-to-side distortion of the ship's structure caused by rolling in heavy seas. Effect stresses the ship's transverse frames and bulkheads. So rocking in a ship is side-to-side distortion of the whole structure. So it's caused by the rolling motion of the ship in heavy seas. So kini ang paglihok nga nagbutang sa kabugat sa mga transverse frame sa barko or kanang suporta sa istruktura nga nagdagan sa gilapdon sa barko. Ug ang mga bulkhead or ang dingding nga nagbulag sa mga compartment rather. Kini ang bulkhead is kanang mga dingding nga nagbulag sa mga compartment. So the severity of rocking depends on the intensity of the rolling and ship's design. So I am done with the 7 common stresses. So ari na po sa measures to counteract ship stresses. So the first one is structural design features. There are 4 types of structural design features. First one is longitudinal strength. Ships are designed with robust longitudinal framing to resist hugging and sagging forces. Next, transverse strength. Frames and bulkheads are added to counteract rocking and torsional stresses. Second, double bottom construction provides extra strength and distributes loads evenly, reducing shear and bending stresses. And the last one is reinforced bow and stern areas, strengthened with thicker plates rather to withstand punting and pounding stresses. The 4 main structural design features used to counteract ship stresses are longitudinal strength or resisting hugging and sagging, transverse strength or resisting rocking and torsional stresses, double bottom construction or evenly distributing loads to reduce shear and bending stresses, and the last one is reinforced bow and stern areas, withstanding punting and pounding. Loading and ballasting practices. So there are three types of loading and ballasting practices. First one is proper cargo distribution. Evenly distribute cargo weight to avoid excessive shear forces or uneven loading which can amplify sagging or hugging. Next, ballast management. Adjust ballasts to maintain an even keel and reduce stress concentration, especially during unloading on raw weather. And the last one is avoid overloading. Adhere to lead line marks to ensure the ship is not overloaded, minimizing structural strain. So to minimize ang ship stresses. So natay sa proper cargo distribution, even weight distribution to avoid excessive shear forces, and in ballast management, adjusting ballast for even keel and reduce stress concentration. And the last one is avoiding overloading. Adhering to load line marks are crucial practices. Third one is operational measures. There are three types also: speed adjustment, course alteration, and weather routing. So speed adjustment, reduce speed in raw seas to minimize pounding and slamming forces. Course alteration, change course to avoid hitting waves head-on, reducing torsional and slamming stresses. Weather routing, use weather routing system to avoid areas with raw seas and high wind conditions. So in operational measures to reduce the ship stress include speed adjustment or reducing speed in raw seas. Next is course alteration or avoiding head-on wave impacts. And the last one, weather routing, using weather system to avoid raw seas and high winds. Fourth one is monitoring and maintenance. There are three types also: stress monitoring system, regular inspections, and maintenance of structural integrity. So stress monitoring system, modern ships are equipped by stress monitoring system to provide real-time on hull stresses, allowing timely corrective actions. Next, regular inspections, frequent inspection of critical areas, example, keel, bulkheads, and framing, help identify and address structural issues early. And last one is maintenance of structural integrity, repair cracks, corrosion, or deformation in hull plating and frames promptly. Maintaining a ship's structural integrity involves stress monitoring system or providing real-time data on hull stresses, regular inspections or critical areas to identify issues early, and the last one is prompt maintenance, repairing cracks, corrosion, or deformation. Next, the fifth one is use of bulkheads. There are two types: watertight bulkheads and corrosion bulkheads. So watertight bulkheads limit the spread of flooding and enhance transverse strength. Corrosion bulkheads protect the ship from damage caused by head-on impacts. And the last one of the measures is the sixth one is dynamic stability management, and there are two types: anti-roll systems and trim optimization. Anti-roll systems use stabilizer fins or gyroscopic stabilizer to reduce rolling and its associated stresses. And the last one is trim optimization, maintain an optimal trim to distribute evenly across the hull. So this section discusses the use of bulkheads in ship construction, specifically watertight and collision bulkheads, Watertight bulkheads contain flooding and enhance structural integrity, while collision bulkheads protect the ship from damage. So dynamic stability management involves anti-roll system and rim optimization to minimize rolling motion and reduce stress on the ship's structure. Proper trim ensures even weight distribution, leading to better stability and efficient operation. Incorrect trim can use instability and increase stress on the hull. So thank you. That's all for for my discussion rather. And thank you. I am Shipman Jacinto from G2C.